So yes, when we read through these two studies, we see that they're both trying to determine something about cell phones and brain tumors and the relationship between the two. But what are the major differences between these two studies?
One's watching for the outcome, and one's pushing to influence the outcome.
That's a great way to describe it. One of them is just looking at what has happened naturally, and one of them is influencing the study in some way, modifying in some way, controlling in some way to see actual differences. Does anyone think of any other big time differences between those two things?
One of them, the study's on rats and the other one on humans.
One of them's on rats, one of them's on actual middle-aged women in the UK. Interesting. So what we get down to is when in research, when we wish to determine how varying the amount of what is called an explanatory variable affects the value of what's called a response variable. So in both of these studies, we were trying to see if the explanatory variable of cell phone usage had some sort of response to an increase of brain cancer, brain tumors. We had an explanatory, what could explain what's happening, the reason. Ignore my TV, it keeps cutting in and out, it's fine. Versus the response variable, what we're looking to see if there is some sort of change in. The major differences here is that one of them is called an observational study. An observational study measures the value of that response variable without attempting to influence the value of either the response or explanatory variables. That is, in an observational study, the researcher observes the behavior of the individuals without trying to influence the outcome of the study. Which one of these two was an observational study? The example one, we just observed what was happening. On the other hand, if the researcher randomly assigns the individuals in a study to groups and intentionally manipulates the value of an explanatory variable, controls other explanatory variables, and then records the value of the response variable, that's called a designed experiment. Those are the two categories of studies that you'll see in statistical methods. You'll see an observational study where we're just viewing what is happening, and a designed experiment when we are influencing on purpose what is happening, intentionally manipulating the value of the explanatory variable and controlling as many other things as possible. So the question really becomes, and this is flipping to the next page, which one is better? A designed experiment or an observational study? So to explain this question, to answer this question, let's consider this third study. It's called Do Flu Shots Benefit Seniors? Researchers wanted to determine the long-term benefits of the influenza vaccine on seniors aged 65 years and older by looking at records of over 3,600 seniors for 10 years. Notice my seniors in high school. We're not talking about you. We're talking about elderly seniors. The seniors were divided into two groups. Group 1 were seniors who chose to get a flu shot, and Group 2 were seniors who chose not to get a flu shot. After observing the seniors for 10 years, it was determined that seniors who get flu shots are 27% less likely to be hospitalized for pneumonia or influenza and 48% less likely to die from pneumonia or influenza. Let's have a little discussion, right? Hooray, wow, these results sound super great. Does that mean that all elderly seniors should go out and get a flu shot?
No.
Why not?
Because it's not 100%.
Well, not 100%, but if you're trying to reduce your risk of getting the flu, doesn't that sound pretty good? For every single senior, no matter what?
No, because there's two groups.
There's two groups. There was two groups that we were studying, a group that got it and a group that didn't. But we compared those two and we saw better results in the group that got the flu shot. What is this study missing for us to really be able to concretely say, the flu shot definitely means that you won't are at a lower risk of getting the flu? What have we missed? What have we not talked about in this study? Let me rephrase. What kind of study is this? Is it a designed experiment or an observational study? Observational. So have we influenced this in any way? Have we controlled for other variables? No. What if the seniors who naturally go to get these flu shot vaccines are the ones who are healthier to begin with? They're more mobile. They're able to leave their home. Maybe they're more worried about their health, so they're taking proactive steps. Means they're probably eating better. They're probably exercising more. There's more things that might be going in to this study, and if we don't ask more questions. It does sound good. And if you're trying to convince your grandparents to go get a flu shot, sounds good, right? But we really want, with statistics, to be able to tell exactly what's happening in a study. Otherwise, we get a phenomenon called confounding. A confounding happens in a study when the effects of two or more explanatory variables are not separated. Therefore, any relation that may exist between an explanatory variable and the response variable actually might be due to some other variable or variables not accounted for in the study. Most specifically, we're looking for two types of variables. When researchers know, kind of like I expressed before, that there may be a confounding variable that we know about beforehand. We know that seniors who are more mobile, aka not like bedridden or they're still able to drive, are generally more healthy because they're able to live a more independent life. That is a confounding variable for this study. It is a second explanatory variable that might exist in the study. You as a researcher might know that exists and just talk about the confounding variable in your study. On the other hand, what we're afraid of the most is what's called a lurking variable. A lurking variable is an explanatory variable that was not considered. We didn't think about it, as opposed to when we did consider it as a confounding variable. So lurking was not considered in a study, but it does affect the value of the response variable in the study. In addition, lurking variables are typically related to the explanatory variables considered in the study, just not with the idea of it being an actual confounding variable. So even after accounting for all of the potential lurking variables in a study, authors of the influenza study from above were still careful to conclude that getting an influenza shot is associated, circle that word, associated with a lower risk of being hospitalized or dying from influenza. The authors used the term associated instead of saying the influenza shots caused a lower risk of death, because the study was only observational. So when we're looking at these observational studies, which is what this was, we just looked at the seniors, let them live their lives how they wanted to, and just took note of what happened. That's an observational study. They do not allow a researcher to claim causation, only an association. Causation, have y'all seen that word before? What's the root of the word causation? Cause. What normally comes after cause? Cause and effect. Causation is a cause and effect relationship. In other words, all that we can say when we're doing observational studies is that there is some relationship, some association in some direction, positive or negative, for these two variables. We can't say one causes the other. But in a designed experiments, on the other hand, are used whenever control of certain variables is possible and desirable. This type of research does allow the researcher to identify certain cause and effect relationships, or causation, among the variables in the study. So if that's the case, if observational studies only allow us to claim association, not causation, why would we ever conduct an observational study if we can't decide something cause and effect? Why would we do observational studies to begin with?
Watch and see, just to maybe as a first view.
Okay, I like that. We're going to write some of these down. So this is a great beginning point. Or initial studies, right? It gives a good idea. We're like, okay, we see this association through observation. Then we can go do something else. Why else would we want to do an observational study?
So then comes natural, not influence.
True. Maybe if we want to see everyday life. Okay, so that's a good one. So if we're wanting to see something that has to do with everyday life, things that happen naturally with no influence. What about studies for the brain tumor example earlier? Why would we want to do an observational study for that one instead of an experimental? It's dangerous. Would you actually sign up for a study if you were told you're exposed to something that could cause brain cancer in humans? Is that ethical to do that sort of study? No. So a big part of statistics is making sure that your ethics is correct in your study. It's a big thing in science and in statistics is whether the experiment is ethical, which is why that second example moved to mice. Okay? Some other examples that we might not think of right away is money. It is way cheaper to send out a survey and get observational studies done, right? You can get a really good survey for a couple $100 and send it out to a bunch of people. That's way more economically sound than having to control variables for a lot of things. They also have a benefit for time because they can go a lot longer than designed experiments. You can observe people for 10 years at a time, but if you were trying to influence their life for 10 years, probably somebody would stop coming to your study. They'd drop out. Okay? There are a lot of benefits to an observational study, even though it only gives us an association instead of causation. So let's break that down a little bit more. So most of the rest of this chapter is going to talk about those designed experiments and how to create them, how to get your sample out of your population, all of that good stuff. But what we need to focus on here is the various types of observational studies. So again, we've got a lot of vocabulary. This is a lot of words, and I feel like if I read it at you, it would get super boring. So what I want you to do is I want you to read the three main ideas here of the three types of observational studies that we have. We have our cross-sectional studies, we have our case control studies, and we have our cohort studies. And we'll finish reading after lunch because that was the first bell for lunch. We have 2 minutes till we go. I want you to read through here and see if you can figure out a good definition for these three things for yourself. All right, so our three main types of observational studies, again, are the cross-sectional studies, the case control studies, and the cohort studies. The main ideas I want you to take away from these is that cross-sectional studies collect information about individuals at a specific point in time or for a very short period of time. So these are your small ones. They're cross-sectional because they look at multiple things to assess different risks. Case control studies are retrospective. That word retrospective means that they require individuals to look back in time. Retro is looking back. So they require the researcher to look at existing records, but they'll be matched with similar groups of people to then decide some sort of association. The last one is called a cohort study. This is probably what you guys are more used to thinking about in regards to observational studies. They are prospective, which means they look over long periods of time, kind of looking towards the future. I think the best explanation of this cohort study is that example in the third paragraph there. It says one of the largest cohort studies is the Framingham Heart Study. In the study, more than 10,000 individuals have been monitored since 1948, and the study continues to this day with grandchildren of the original participants taking part in the study. So not only have we seen one generation of people from 1948 through now, if they're still alive, we've also seen further family lines and the study of heart disease, which is really cool. But look at that cost. It's in excess of $10 million. So we're talking about really expensive studies across many individuals. So let's talk again. So why would we conduct an observational study? What were some of those reasons that make us choose observational versus experimental? Shorter time, yeah. Less expensive. We get into the ethics again, what you can and cannot experiment on actual human beings. And again, it's a good place to start with an observational study and then do a designed experiment afterwards when you have a good idea. Some other sources for observational studies, so these are not types, but just places that researchers will go to find observational studies, is the census. A census is a list of all individuals in a population along with certain characteristics of each individual. The U.S. Constitution requires a new census every 10 years, so the next one you guys will participate in 2030, because 2020 was the last census. And they work really hard on the census because I forgot to turn mine in and they straight up called me and I had to answer the census questions on my phone. But this is a really big way for researchers the government aside to decide, you know, like how many representatives in the Senate and all that good stuff, how many of those we have via the census, but also researchers can take that information and use it to identify individuals they want in a study. You also can get good sources for observational studies is called web scraping. You guys will probably have heard it known as data mining. Do you know what that is? Oh, you really don't know data mining? Guys, y'all are all up on the internet. You should know about data mining. You know how you get targeted ads? That's data mining. They use they extract data from the internet retrospectively and prospectively to determine what ads to show you. That's one use of data mining. Or you can use it in statistical methods to find those observational studies that you want to do. It's a great place for data to be given to you live in time with real human interaction, or over time retrospectively for internet usage. Other places, you can just download them from the internet. A lot of government agencies, companies, and sports organizations make their data available to the public. So like baseball is a huge sport for the statistics because you can look at so many stats when it comes to baseball. Those are all published by the sports organizations themselves. So you can find all that info in a CSV or Excel file or a TXT, which is just like text file. And then you can use it in Excel, in your calculator, in whatever stat crunching capabilities you have. So we have a lot of vocabulary words again. We had all of the different types of studies, your observational versus your design experiment, and then the types of observational studies. That is all of the vocabulary we're going to need for these two sections.